Alright, this will be the third video in the series of algebraic facts and operations that first semester college students should know. So let's get to it here. The first few that I have here are the ones that I did in the first couple of videos. So I'm going to just scroll down through them. You can pause the video if you want to look at those. The answers are given there. There's the problem dealing with order of operations. Again, these are the answers to those problems. So like I said, pause the video if you want a closer look at those. Okay, the ones for this video will start here. Solve each of the following as indicated. So in the first one, simplify 4 over radical 2. This simply means, again, when you're dealing with radicals, you don't want you don't want your answer to have you don't want your answer to have a radical in the denominator. So it's okay to have it in the numerator, but not the denominator. So what we do here is we try to set it up so the denominator has a perfect square. So we multiply the numerator and the denominator by the square root of 2. So in the numerator, I'll have 4 square root of 2. And if I multiply these two out, that gives me the square root of 4. The square root of 4 is 2. And then these never divide into a radical here. Okay, numbers with numbers, radicals and radicals. So here we divide the 2 into the 4, we get 2 radical 2. Okay, so you should pause the video when I get to a problem and then see if you can work it out, and then check your answer. Perform the indicated operation on the next one. So let's clear this. You can start working on it and pause the video just to test yourself. Okay, so now I'm going to work it out. We have 5 plus radical 3, 5 minus radical 3, just like a plus b times a minus b. It's a squared minus b squared, the same thing here. We have the sum and the difference of the exact same terms. It's always going to be the square of the first one minus the square of the second. Okay, so radical 3 times radical 3 is radical 9, which is 3. So that's 22. Okay. Clear. Go to the next one. Solve this equation. Okay, pause it. Shouldn't take you more than a few seconds to solve it. Okay, now I'm going to solve it. This is a basic linear equation. You come into college and you take college algebra. These are the things that you're going to have to know. Okay? Some of the things. Okay, so I'm just giving you a sample. Some of the types of problems you should really know how to work before you get into a course, say like college algebra. So here we're solving a linear equation. We want to isolate the variables. So we want the x's on one side, constants on the other side. So here I can add a negative 2x to this side, and negative 2x to this side. So if I do, this will give me an x. Negative 2x and 2x, it cancels. So I get x minus 5 is equal to 7. And then again, to isolate the x, I want to get rid of this 5, so I add 5 to both sides. So minus 5 and 5 cancel. On the right side I get 12, 7 and 5, so I get x equal to 12. Okay, clear this. Okay, the next problem, solve by factoring and using the quadratic formula. Okay, this is a quadratic formula. Quadratic equation, I should say. And generally a quadratic equation is one that has this type of look. ax squared plus bx plus c is equal to 0. And normally if you're going to factor, if you're going to solve a quadratic, you can solve a quadratic by either factoring. If it doesn't factor, then you want to use the quadratic formula, or there is also a method of completing the square. But you don't really need completing the square if you know the quadratic formula. So always try to factor it. This example, we want you to do it both ways. Okay, so I'm going to pause the video, or you pause the video, and see if you can solve it, and then I'll work it out. Okay, so here we go. I want to write it in this particular form here, so I'm going to write this as x squared minus x. Bring the 6 over, change the sign, you get equal to 0. And then this can be factored. Okay, if it doesn't factor, then of course you always want to try the quadratic formula. But this one here is going to give us x minus 3. It's one factor, and the other factor is x plus 2. And you can always check yourself by multiplying it back and make sure you get the original expression on the left. Now once you have it factored out, and this of course works even if you have an expression that factors into, say, more than 2 factors, 3 factors, 4 factors, 10 factors, works the same way. As long as one side is 0 and the other side is factored out, the only way this product over here can be 0 is if one of the factors is 0, or all of them are 0, in this case 2 of them. Set each factor equal to 0. Once you have it out, and solve it, you get x minus 3 can be 0, or x plus 2 can be 0. Okay, solving each linear equation now for x, add 3 to both sides of this one, I get x equal to 3. Add negative 2 to both sides here, I get x can be negative 2. So my solution then for that one is x can be 3 or negative 2. Okay, so this is your solution using the factoring method. Now if we use the formula, this says, okay, you can solve it by setting it up this way. Whatever b is, you take the opposite, plus or minus the square root of this expression here. Square the b minus 4 times a times c. Okay. Well, in our case, a is going to be 1, coefficient of the square term. B is going to be minus 1. And c is going to be the other constant, negative 6. Okay, so there we have it. A, B, and c. And then we just plug into this formula here. Okay, so numerator opposite of b, b is negative 1, so I take the opposite of that, that's 1, as plus or minus the square root of, okay, b squared, okay, b squared is negative 1, so if I square that, that's 1, minus 4 times a is 1, put it in there, and c is negative 6. Okay, so 2 times a, so this would be 2 times 1. Okay, so then we work inside the radicand here, I get minus 4 times 1 times a minus 6, that's a plus 24. And then a 1 is a positive 25. So this would give me then 1 plus or minus, and then the square root of 25 is 5. and that's divided by 2. Okay, then we just get the answer for this. So one answer could be 1 plus 5 over 2, which means 6 over 2, and that gives us 3. Another answer could be 1 minus 5, which is negative 4 over 2. That gives us negative 2. That's the other answer. Okay, 3 and negative 2. Clear this. Let's go to the next one. This one says, give the slope and x-intercept. Give the slope, x-intercept, and y-intercept of the lines with given equations and graph. Okay, so in this one then, the x-intercept is where the graph crosses. Okay, so let me draw the axis over here. Okay, so it crosses the x-axis. That's your x-intercept. What crosses the y-axis? This is the y-axis here. The x-axis. So notice if I have a point on the x-axis, the first component could be 0, 1, negative 1. Okay. And the second component is always going to be 0. If you're on the x-axis, so this would be 1, 0, 2, 0, 3, 0, negative 1, 0. So basically then, to find the x-intercept, we simply replace the y by 0. Right here. So this gives me 2x is equal to 6. So that gives me 3. So 3, 0 is the x-intercept. Now for the y-intercept, see right here, we're in the origin, 0, 0 is both an x and a y-intercept because it lies on both axes. If I go up 1, that's 0, 1. Another one, 0, 2. If I go down, 0, negative 1, 0, negative 2. So the y-intercept always has the first component of 0. So to find the y-intercept, just replace the x by 0. So if I replace the x by 0 on the equation, that leaves me negative 3y equal to 6, so y is negative 2. Okay. Now to graph it, well, let's see the slope. The slope, you can use the 2 points to find the slope, or if the equation is solved for y, say y equal to mx plus b. This is called the slope-intercept form because it turns out that if you haven't solved for y, the coefficient of the x is going to give you the slope. That is the slant of the line. So if the line is going up like this, the slope is going to be positive. If it's coming down this way, the slope is going to be negative. So this equation or formula right here tells me that if you haven't solved for y, whatever multiplies the x is your slope. And then the other number, if there is another number here, if there isn't, that's 0. That other number will correspond to the y-intercept. So in this case, it would be 0b. Okay? Or if it doesn't have a b, it'll be 0, 0. So the line will pass through the origin. Okay, then for your graph, 2 points determine the line. So just plot the intercepts. So 3, 0 is your x-intercept, and 0, negative 2 is your y-intercept. So the line passes through those 2 points. Okay. So notice y equal to 5x. Oh, I'm sorry, y equal to 5. There's no x there. So well, let me go back. I didn't give the slope. So for this particular one here, let me solve it for y. Okay. Didn't give the answer to this one. So negative 3y is equal to negative 2x plus 6. If I divide by negative 3 to solve for y, in other words, I want it in this form right here. This is just one way to get the slope. You could use the 2 points and use the slope formula for that. But in this case, I'm just going to do this. Divide by negative 3. coefficient of the x is positive 2/3, and then this minus 3 into the 6 is minus 2. So in this particular form here, the slope is m, and b is the y-intercept, which is what I have. Notice here, 0, negative 2. Okay, right there. That's the y-intercept, and this is your slope. So for the first one, the slope is 2/3. Okay. Now, for the third one, y equal to 5 is always a horizontal line. Okay, y equal 5. If the equation doesn't have an x, just a y, it's going to be a horizontal line. If it just has an x, like the third one, and no y, it means the coefficient of the y is 0. Over here, the coefficient of the x is 0. Okay, so if it just has an x, it's a vertical line. So for this one right here, let me just graph it and we get the information from that one. Okay, so for y equal to 5, the y-intercept is going to go 1, 2, 3, 4, 5. The y-intercept is 0, 5. Y-intercept is 0, 5. Notice there is no x-intercept. For y equal 5 doesn't cross the x-axis. No x-intercept. And the slope is 0 because the coefficient of the x is 0. So in other words, horizontal lines always have a slope of 0. Now, for the next one, x equal to negative 3, that's the vertical line. Okay, so there's no y because the coefficient is 0. So we plot negative 3 over here, and it's always going to be a vertical line. This is your y-axis here, your x-axis. So this one has no y-intercept. No y-intercept, doesn't cross the y-axis. The point negative 3, 0 is your x-intercept. And the slope is undefined. Okay? So horizontal lines have a slope of 0. Vertical lines have a slope that is undefined. Okay, let's clear this here. Again, pause the video as you need to. For the next one here, simplify. Okay, so again, pause the video and see if you can get an answer to this, and then I'll work it out. Okay, so I'm going to work it out here. Again, this is just basic multiplication of monomials. Multiply the coefficients with the coefficients, and then x and the x's, the y and the y. And here the main thing is to remember that for laws of exponents, when you're multiplying powers of the same base, you add the exponents. Okay, so here we just multiply the 2 and the negative 4. That's a negative 8. Okay, bring down your bases one by one. So it's x. I got an x to the third, an x to the 8th. Okay, powers of the same base. You add the exponents. 3 and 8 is 11. You get this. Bring down the y. Okay, y and y. Power of 7 here. Power of 1 here. Again, add the exponents. 7 and 1 is 8. There you have it. Okay, clear this, and this is the last one for this video. Again, when you're dividing, okay, we bring down the base and subtract exponents. So keep in mind that if you have a, okay, again, pause the video. You want to work this on your own, and then come back and check my answer. Okay, so pause it. and solve. Okay, so if you have a to the negative n, negative power, that's the same thing as 1 over a to the n. Okay, so in other words, you have it like this. You bring this to the denominator, it changes the sign. Just like when you move terms from one side of the equals to the other, it changes the sign. Same sort of thing here if you're dealing with the numerator and the denominator. So 2 to the negative 3 would be the same thing as 1 over 2 to the third, or 1/8. Okay, if you have it down here, you can rewrite it, take it to the numerator. This becomes 2 to the third, and this stays 1 down here, so that's 8 over 1, which is 8. Okay, so that's how that works. So now, and this one here, again, just like with the multiplication, this kind of works the same way except it's division. So I have 12 divided by 4. So we can just do the numbers. 12 divided by 4 is 3. Okay. And then here, we usually want the answer, unless stated otherwise, we're going to want the final answer just with positive exponents. We don't want to deal with negative exponents. So I could bring, I'll do it this way. Let me just do it this way and say, okay, bring down each base. So it's x to the negative 2 over x. Okay, so I could just say, okay, if I'm dividing, when you're multiplying powers of some base, of the same base, you add exponents. When you're dividing powers of the same base, we subtract. So I could just say here, this would be negative 2. This x over here has an exponent of 1. This would be subtract 1. Okay, bring down the y. Okay, so it'd be 4, subtract negative 2. 4 subtract negative 2, that makes it a plus 2. Okay, so I'll put a plus 2 like that. Okay, and then z. So this will be negative 3, subtract 5. Okay, so then this is going to equal 2. 3, x minus 2 minus 1, that's minus 3, y, and then exponent 4 and 2, that's 6, and then z, minus 3 minus 5, that's minus 8. Okay, and then we want to write the answer so the exponents are positive. So in this particular case, then all we have to do is this, x to the negative 3. We wanted x to the positive 3, just take it to the denominator. That's another way to do it. Okay, and then this is just going to be y to the 6. That's already positive, so that stays in the numerator. Z to the negative 8. Okay, bring it to the denominator. Z to the 8th. That's your solution. Okay. That'll conclude this video. Hopefully I'll have more examples like this in the next video. Thanks for watching. See you next time.